Hi, everyone. This is Jason Key at SBGrid at Harvard Medical School. Thanks for joining us today. First, to start, I'd like to just a couple of announcements. Note that we have next month, Thomas Grant will be giving a webinar. This is going to be Thomas's part 2 of his small angle X-ray scattering webinars. So uh, if you didn't catch the first one, it is recorded and available on the SBGrid TV channel. So, and then he will follow that up on the 18th. So, looking forward to that. Today, I'd like to talk about getting started with SBGrid, sort of an introduction to the programs tree, a little bit of general information about SBGrid, what we're doing. If you have questions during the talk, feel free to interrupt by chatting me in the chat window. I can chat here. The new version of Fuse, if you'd used the old versions, is a little different, but things are not as easy to find, in my opinion. But performance seems to be pretty good, so we'll go with it. All right, and with that, I'll get started. About SBGrid. SBGrid is a nonprofit consortium. We're based at Harvard Medical School, and our focus is really on structural biology computing. We are structural biologists, IT pros, software engineers, programmers. We have software policy advocates in the group. We have postdocs, occasional student. And we're really focused on the structural biology community on a whole. We are involved in hardware here at Harvard Medical School. We have the SBGrid software tree, which is sort of the main focus of the group. But we also have advocacy and outreach efforts. We have some research projects that are ongoing within the group and some students that we're training. So we are an academic group. We are primarily focused on our software collection. Right now, the software collection stands at about 290 apps. These are for Mac and Linux. We do not support Windows and don't plan to in the near future. Right now, we support Mac 10.6 to 10.9 and unofficially 10.10. I mean, we don't turn anyone away with we also support CentOS 5 to 7. We will probably phase out Cent 5 by the end of the year, though there are a lot of Cent 5 machines out there. So again, we do our best to support as much as we can. Officially, we'll only support 6 and 7 early next year. But even folks who are running Ubuntu, Debian, SUSE, we do our best to make it work. So, and we have an infrastructure here where we have virtual machines of most distributions. So, and we test the software on a lot of those. We support 64-bit Linux. We support 32-bit Linux, but increasingly that is less used. And if anyone out there is running 32-bit Linux, I'd encourage you to upgrade. We still have PowerPC applications in the tree for anyone who has that old application that was only available in PowerPC or even IRIX. But those platforms are becoming less and less used, and in these days are more of a sort of historical artifact. So let's talk a little bit about the SBGrid programs tree. So the programs live in /programs. That's required on all systems. That's hard-coded library paths for some of the binaries. So that has to be, I mean, you can use a symlink at /programs to, op programs or whatever your system administrator prefers, but that's where the programs will be. The structure of the programs tree is /programs. Then we have an architecture level. So that would be x86 64 or our Mac. And then following that, we have the application name. So those are a lowercase name, familiar, sort of the standard name of the application. And then within that directory, we keep the versions. So We maintain 3 versions for most applications. Often we have a lot more. So for certain things like HKL 2000 or CCP4 or Phoenix, sometimes we have 5 or 6 or 7. Sometimes people start a data processing effort and get halfway through and decide they need a certain version and want to go back. So we keep the older versions for those purposes. We update the applications every month. Sometimes it's more often than that. If major problems arise, if bugs are revealed in applications that a lot of people use, let's say Phoenix or Pymol, then we get those in as fast as we can and just push those out. The bulk of the applications in our collection are open source, but we do have several commercial applications and some things that are in between that are not necessarily, they're definitely not commercial, but they're not open source. They require registration or a licensing agreement. But so in program/share, there are data and libraries that are shared between applications. But that's also where we keep our SBGrid stuff. So the SBGrid tools and utilities live in there, and the tools we use to maintain and synchronize the programs tree are in /share. And we also, some sites have a /local. You can put a program/local in your programs tree. I highly recommend it. You can install applications there and or symlink things. You can put licenses in there. It's a directory that will not be overwritten when we do the updates to the programs tree. Everything else will be. So everything in the architecture directories, everything in share will get overwritten, but programs local will not. So how do you find out what's installed? So the easiest way is probably just to go to sbgrid.org, go to our website. Under supported software, you can click on supported applications. We have a new website where applications are broken down by sort of category by field, where field would be crystallography, electron microscopy. Or you can just crack open a terminal and take a look, CD over to programs x86-64 and list the applications in there. Getting most of the software in the SBGrid tree is run from the terminal. Some things you can run from graphically by clicking an icon, but it's mostly terminal. So what we have is a shell script that will configure your environment in either Bash or C shell to use the it will configure your environment for all the environment variables paths that you need to access the SBGrid programs. So we also have tools that we've written to help you work with the software. So I'd like to talk a little bit about some of these tools. The main tool that I find useful is there's a command line tool called just SBGrid. And so what I've shown here is the usage info for that. But the SBGrid tool takes as an argument a program name and will output information about that program. So I'm just going to switch out here. So let's jump over to the terminal here. Hopefully you can see my screen. So if I want to know about, CCP4, I can just SBGrid. Oh, sorry, you have to actually source the programs tree first. So when you source the programs tree, you get information. You get how to put in bug reports, help requests, and you also get this installation last updated entry. So it tells you, when your install was last updated. That date will be colored green if it's up to date. If your date is red, likely you're not getting updates. You should drop us an email. All right, so now that my environment's set, I can do SBGrid -L and do CCP4. And so this tells me in my programs tree now, I have the default version is 6.4.0. I have other versions, 6.3, 6.2. And if I want to override this version, there is a shell variable I can use, and I'm going to talk about that in a little more detail in a second. Back to the slides here. SBInfo is another tool that we have in the tree. This is a nice tool to use if you're reporting a bug or you're having problems, just to run SBInfo and cut and paste it into your email to us. It's gives us your operating system, your installation site, when you last updated, and this helps us quite a bit in figuring out who you are, where you are, what you're running, and what may be going wrong with your system. SBWitch is another tool that we have in the tree that is analogous to the Unix command line tool Witch, but it's specific to our software environment. So in our software environment, because we have 290 plus applications, not everything is in path. Some things use aliases to their full full path, so that we don't have to make the path enormous in your shell. So SBWitch will allow you to use Witch with aliases and tell you what programs you're running. I'll show you a little bit more about that in a second. The other utility we have that I think is particularly useful is we have SBGrid Locate, which uses index databases of the tree to find specific files. So if you wanted to find a specific file within the programs tree, you don't have to do a big find on your file system to find that file. And I'm sure your system administrator would appreciate it if you didn't run find on the entire programs tree on their file server. But so this is low overhead and fast. So this is a nice way to find something if you're looking for it. So version overrides. So you can specify a version of any of the 3 or 4 or 5 versions that we have for any application in the tree, Mac, Linux. And the way you do that is you create a file in your home directory called .sbgrid.conf. And in there, you specify a shell variable and just specify the version of the software you want to use. So I'm showing the syntax here, but let me just walk you through. So here, SBGrid CCP4, let's say I wanted to use version 6.2.0. So I would just open this file, and it said that my variable is going to be CCP4_X. So it's _X for Linux, it's _M for Mac. And I want this to be 6.2.0. Great. So now when I change that, I have to reload the environment. So I'm just going to resource the programs tree. So now in the message that it's showing me here, you can see it's showing my configuration options in effect are setting 6.2. And now if I jump in with SBWitch and do CCP4, and it's not going to kick anything back for CCP4 because there's not anything called CCP4 in paths. It's CCP4i. It tells me I'm running 6.2. So the override is in effect. You can do things like for Phoenix, we have a nightly version. So you can just specify in here that you want to run the nightly and resource the shell. So now it's going to run the nightly. And if you do an SBWitch, it'll pull up the nightly. So that's how you do version overrides. It is possible for your system administrators to, or if you are the system administrator, to do a site-wide version override. If you're interested in doing that, we have information about that on the SBGrid wiki on our website, or just drop me an email if for some reason you wanted to lock down a version for your entire site. All right, so structural biology labs historically have had the same setup or very similar setups for the whole lab, where you have a central file server, and then you have either NIS to authenticate users, and then NFS to push out home directories and software. More and more labs are getting away from this. People are working at their desks just with a laptop, and at the end of the day, they pack up and take their laptop home. So you're not, it's not very conducive to NFS mounting your home directory if you're working on your laptop. So we've got two ways you can install the SBGrid programs tree onto a laptop. These are both shell script install utilities. One is SBGrid-sync and one is SBGrid-laptop. They're essentially the same. There are a few minor differences, but the key distinction is that one allows you to install from our servers. So you have an SBGrid account. You can email us if you don't know if you have one or you'd like to have one. And then you can install directly from us. And that's easy. It involves less configuration on your end. The other way you can do it, which is probably faster in terms of bandwidth, is to do the SBGrid laptop script. This allows you to specify a machine that you probably have on your local network, which has the programs tree, and sync directly from that. So both are fine. And if you're close to Harvard, or Harvard's got great bandwidth, so, but we're not going to beat syncing across the room. So if you want to sync from your own file server, grab the SBGrid laptop. Both of these are in the SBGrid programs tree, and they're in program share bin. So you can, they're up to date, and we update them as we push out the software when we need to. If you have trouble finding them or running them, drop us an email. All right, so for some things in the SBGrid programs tree, like some of the things that you use all the time, like Pymol and Chimera, if you're a Mac user, you can just add icons to your dock for these .app bundles. And now that you sort of know where the software is, it's pretty easy. So I'm just going to jump over here and get rid of this terminal. So, and in fact, maybe I'll just connect to my Mac. So oops, you do have to type in the correct password. All right, one more try. All right, let's try that a different way. So if you go to the SBGrid programs tree, you can use the locate utility that I discussed before, SBGrid-locate, to find things that end in star.app. Those are going to be the app bundles. And let's say we want Pymol. Nope. You do have to source the programs tree, which you should have set in your .bashrc or your .cshrc. I'm working on my laptop today, so I don't have it set that way. But so we're good. All right. So let's look for .apps. So there we go. So that pulls up all the .app bundles for Pymol. So if you want to add this to your dock, you just crack open the Finder, navigate to /programs, i386 Mac, pick the version that you want. It'll be there, show up like just a standard Mac icon. Just drag it into your dock. It's super easy. You can do the same with Chimera, has an app bundle. Genius does. There's a handful of others. So if you're curious about an application and you want to add it, this is the way to go. There are certain things that you just are not going to have great luck with, like Coot, for example. But for things like Pymol, Chimera, things that are packaged as .app bundles, it's easy to add them to your dock. All right. So aside from the software collection, we do have other resources that are available to consortium members or the structural biology community as a whole. One is our Open Science Grid portals. So currently we have 2 portals that are back-ended by the Open Science Grid. Open Science Grid is a sort of cluster of clusters that are a high throughput computing resource created by the particle physics community that allow us to use their computational resources for structural biology. We use this in two ways. One is we have what we call wide search molecular replacement, WSMR, and then we have this deformable elastic networks low resolution refinement. The wide search molecular replacement is nice if you have a molecular replacement problem that you've been struggling with and you have some uncertainty about your model. With WSMR, you can do a molecular replacement search against all known domains in sometimes less than 2 days. So this can be as much as 50,000 hours of compute time, 120,000 molecular replacement jobs. And we've had a number of users who couldn't get derivatives or otherwise couldn't reproduce their crystals and were able to get a foothold for phases using this approach. So I don't know that I would go there first. Most people know what they've crystallized and they can do a fairly decent job of screening their own models, but sometimes it's worth a shot. And if you're in that position, by all means, portal.sbgrid.org, create an account and give it a try. We have the Schrodinger suite is installed in the SBGrid tree. It's not there by default. We only do it by request because it's pretty big. It's like 5 gigs. But we do provide a computational backend for virtual screening with that. So we have a small multi-core machine. It's 32 cores at the moment that you can run virtual screening jobs on. That's easy to configure from within Schrodinger's Maestro graphical interface. You can configure the host and dispatch jobs directly from the interface. You don't have to SSH over or log in. You do have to configure passwordless SSH keys, which is you do it one time and then you're all set. And it's pretty straightforward. We have a global phasing Sharp server. So if you're interested in using Sharp, let us know and we can create you an account. You can log on and run Sharp jobs on our computing hardware. And as I noted before, we have the SBGrid TV channel where we record these webinars with developers for scientific and structural biology applications. So the last few were sort of general use applications. So we had a couple Genius webinars, and so it's mostly structural biology, but we do have some general use biology tools in the tree. So, and the Genius folks have been great and have given us some great webinars. One other thing that I would like to point out is that we can help users who need more computational resources get access to XSEED. So XSEED is the Extreme Science and Engineering Discovery Environment. You can find more information here at xseed.org. So XSEED is sort of an overarching organization that attempts to create a virtual system that scientists can use to interact with multiple clusters. These are clusters at the San Diego Supercomputing Center, the Texas Advanced Computing Center, and other supercomputers around the US. You can set up an account here, get a single log on, do a single startup allocation for multiple sites. And the goal here really is to lower the barrier for people to get started with HPC, with high performance computing. If you're working in a field where, particularly in cryo-EM, and you've got loads of data and you need to run Relion and FreeAlign and you need thousands of hours of compute time, we've helped a number of people get started on these resources. So yeah, by all means, reach out, let us know. I can help you get there. Finally, I wanted to note that you can get startup allocations on these resources, and then you can sort of pilot your your workflow and make sure that this is going to work for you. And it's pretty straightforward, and I can walk anybody through it who is interested in going this route. All right, so getting help. So we have new forums that we've rolled out. So these are brand spanking new. We have, in fact, I think the only people who've posted in there are members of our own group. I encourage you to take a look. We've put in a few articles, just general how-tos. We'll keep adding to these. If something's missing and you'd like to see it, let us know. We also have the standard bugs@sbgrid.org email, the sbgrid.org website. You can submit tickets through there. One thing that we'd like to accomplish with the forums is we end up, in some cases, troubleshooting tough bugs or working through situations where other users would benefit, and they could just find that information straight away on the forums. So we'd like to sort of build a publicly accessible repository of that information instead of locking it away in our ticketing system. So that's eventually the goal. So we'll see how that goes, and you can sign on with your Google Apps domain. You can create an account over there. It should be straightforward. If you have any problems or trouble, get in touch and let us know.